Alrighty. I am returned. Oh, and my thing is not active. Hold on a minute. I need to move a bunch of tabs around real quick. And then I need to say the opening lines. Grab my iPad. Rub on some hand moisturizer. This isn't scuffed at all, I promise. Yeah. When the world... What was it? When the world is filled with noise, it's time to shift from Gaussian to Poisson. Hey, hey, it's Poisson Invariance, your mathematician and vtuber for the second time today. Oh my god, it's been so long since I've seen everyone. How have you all been? Should I go through all the, pleasantry questions again? How is everyone? Gamer, how was your picnic date? Ado, how are you doing? Anyone see any good movies? Anyone see any good equations? Alright. Let us get this set up. Oh yeah, I guess it is exam season. Because necktie, there's a bunch of people who have, just had exams, or are going, I guess, to have exams. Alright, what was I doing previously on this? Previously, I was messing around with Taylor's theorem, I believe. Was this numerical? Oh. You're age 6 years already. The world is filled with noise. It's a noisy place. I guess it's more of a comment on the fact that, I guess, on misinformation and stuff. I don't know. I didn't really think through the intro. It's very thrown together. But hey, intro's an intro. And you guys can't see my screen. Okay, 1 second. Nope. None of those are correct. Is this correct? Oh, that should be correct. Oh, that's why. The window wasn't turned on. Okay, now it's still not showing up. How can there be this much scuff from switching from one stream to the next? Alright, I barely did anything. Oh, I think I have to do it as a game capture for some reason. Okay, that's weird. Hello? Are you there? Ah, there we go. There we go. Flashbang. Alrighty. Today, if I remember what I said on my thumbnail, I'm in the mood. It was specifically one of my viewers, Kikoto, was doing stuff with Laplace transformations, and I was like, oh, I haven't touched Laplace transformations, or Laplace. I say Laplace because of the VTuber, Laplace, but Laplace darkness, so it's stuck in my head. But Laplace, I was even saying Laplace to my coworker. They're like, Laplace? What's Laplace? And then I started writing out a Laplace example, Laplace transform, and they were like, oh, Laplace. And I was like, yes, sorry, I was just mispronouncing it with the integrals. Yeah, I figured I would just do a few of these, and this isn't even meant to be a teaching thing. I'm gonna be honest, I just want to re-get into the mindset of Laplace transformations and just have fun doing that, because it has been so long and I miss them. Yes, Laplace is very sweet. She's very goofy. I like her. Alright, where's some good example problems so I can get back into the groove of it? Because, like, we have our generic ones. Or it's like, let's look at an example one. Just to hop back into the groove, f of t is equal to sine of a of t for t is greater than or equal to 0. So, if we were to take the Laplace of that, the Laplace transformation, oops, what do we get? We get the function f of s, right? Because we have to convert the variable. I remember this. Yeah, my hands are, my fingers are kind of like slippery because I put like moisturizer on, so I'm just like, I feel like I'm a squid. Some of my concept art for my like future model actually kind of looks very squid-like, and that wasn't intentional. That was before I knew that Poisson was like French for fish, but now it's fitting. So I might go all in. The thing is, I don't like fish. I don't like fish at all. I don't like any like seafood. Last time I was in an aquarium, I had an anxiety attack, but that was also like 9 years ago? 7 years ago. 7 years ago, right. No. 8 years ago, because I wasn't able to drive yet. Right. I remember. This is a very important detail about when I had the anxiety attack in the aquarium. Okay, so we integrate from e to the negative st sine of a t dt, and we know that s has to be greater than 0, right? Okay, and then seafood's amazing. Yeah, okay, when you grow up on an island and all you do is eat seafood, I'm sure you are much more fond of it. I can't do it. I do not care for the fishy flavors. My whole family loves seafood though, and so it right, limit as a approaches infinity, and then we plug that in for infinity so that we can get some actual answers, because by and large plugging in infinity doesn't get us anywhere. Okay, integration by parts, and then, okay, that was just the proof for how that works. Okay, yeah. No, I don't care about proofing it. I was just like reviewing some stuff. No. Ultimately, it was just the Laplace of that. Okay, no. I want to do an actual problem. I'm fine with using my pre-made Laplace tables because I don't want to do proofs for all of those. There we go. Okay, here's a good example. Get me back into the groove. All right, so let's define f of t as 5e to the negative 2t minus 3 sine of 4t. T, of course, is greater than or equal to 0, as it is wont to be. Right, now, if we want to take the Laplace transform, because it's linear, we can go ahead and split it up into both terms. God, I love linearity. But I cannot draw a straight line to save my life. And we can also pull out the constant due to it being linear. Sine of 4t. Okay. Now, if I go ahead and look at my table, so I'm actually going to rewrite this as f of s now. And we know that s is going to be greater than 0, because half the time s ends up on the bottom. Where is my table? I thought I had one in this. Thought I had one ready for me. Oh, there it is. Okay. I need to better prepare for this stream instead of just playing Shin Megami Tensei, but who am I kidding? I'm just gonna play Shin Megami Tensei. Oh, and of course, the 5 can come out again due to the linearity. So we get 5 times, that's 1 over s plus a, and a in this case, or s minus a, and in this case a is -2, minus 3 times, in this case, sine is omega squared, right? No, it's omega over s squared plus omega squared. And omega in this case is 4. F of s is then equal to 5 over s plus 2 minus 3. Oh wait, no, I can multiply that out. 12 over s squared plus 16. Okay, there we go. Remembering how to do these. I bet your family likes it too. My family can like all the seafood they want. Doesn't mean I have to like the seafood, though. In fact, that just leaves more for them. So isn't it a good Samaritan thing if I'm giving them all the seafood that I don't want? I think it is. And with the gamma function stuff and whatnot. No, I want to get into solving IVPs right. Because the whole point of a Laplace transform is so that when we solve an IVP, we can do it by doing the algebra and making our life easier. Okay. The Laplace of the prime of t is going to equal s times the Laplacian of boom, boom, minus f naught. Right. This is going to be our equation for dealing with that. And now, I could prove this theorem, but why on earth would I prove this theorem? That sounds like a huge pain. Instead, let's do this problem. Just a generic IVP where we have y double prime minus y prime minus 2y is equal to 0. We're going to have that y naught is equal to 1, and y prime of naught is equal to 0. So first things first, we're going to find the characteristic equation. We factor out the, what is it? E to the negative RT? No, it's just E to the RT. That's the buffet mentality right there. Just, everything just becomes a buffet. Are you skipping the proof problems? Haha, I feel like, yeah. I'm like, well, so like, I don't need to reprove. I'm just trying to get back into the flow because I haven't done them forever. I like doing the proof problems. It's just like, some of these are just like proof transforms that we already have. Why would I do that? I have the table for a reason. I probably will go back and do some of the proofs though. For now though, I'm just like in a very solver mood, I guess you would call it. Oh, excuse me. Alright, let's see. It's going to be r minus 2 and r plus 1 equals 0. So our r1 set is positive 2, our r2 set is negative 1. So then our characteristic, or our general equation, y of t, yeah, make sure that my face isn't covering up a bunch of that, but it probably is still going to cover up a bunch of that regardless. C1 times e to the 2t plus c2 times e to the negative t. Right. All right, so now we apply our initial conditions in order to find our exact solution. And that would just be saying C1, because we're plugging in 0, plus C2 is equal to 1. Yes. Okay. That gives us that C1, or actually you can do C2, is equal to 1 minus C1. All right. Now let's go ahead and plug that back in and then take our derivative. Y of t we can then redefine as C1 e to the 2t plus 1 minus C1 e to the negative t. All right, now let's take our derivative. Or to be easier, probably take it with this C2. Actually, if I distribute, it shouldn't be a problem. Go ahead and distribute first, just for a bit of clarity's sake. All right, now we're going to take our derivative. Bop, 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 bop. I went from playing SMT to also listening to SMT music while I do math. Story of my life. There we go. Lock my door. I didn't want anyone walking in on me while I'm doing math problems. That'd be embarrassing. Okay. Minus e to the negative t plus c1 e to the negative t. Go ahead and plug in 0, and that, I believe, should equal 0 according to our initial condition. Yep. So we just get easy 2c1 minus 1 plus c1 equals 0. 3c1 equals 1. C1 equals 1/3. Did I do that right? Combine like terms. And then we add the 1 to the other side. Yep. Okay. Now we go ahead and plug this back into y of t to get, and we'll be able to combine those. 1/3 e to the 2t plus 2/3 e to the negative t. All right, so that's our general solution. Oh, just basic, like, characteristic equation Diff stuff. So now that we found our general solution, that's a good comparison for when we go ahead and run the Laplace over the same thing. Right. So we can go ahead and, instead of that, yeah, this question wanted me to do it both ways. Tedious, yes, but that's differential equations in a nutshell. Diff is one of those things that's like, I want to label like each term as like 1, 2, 3, and that'll just be like 2 plus the integral of 3 plus da 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 in order to avoid the bloat of rewriting everything, and that way I can also keep track of everything. Alright, what am I doing? So we can, using the corollary we did up here, we established here, we can go ahead and take the Laplace of y double prime minus y prime minus 2y And then we can expand that. Oh, this is the best song. I'm gonna stop talking just for this segment because I want to enjoy this song. Oh, you can't really see the... Go ahead and bring that down then. My chunky chat gets in the way. So then, here's where it comes up. Now, using the corollary that we previously established, which was right here, we can go ahead and start to rewrite some stuff. We get that s squared y minus s of y naught minus y prime naught minus as the Laplace of y. It's like this whole thing is just from this first term there. Now this is going to come from that second term there. It's minus y naught minus 2 times the Laplace of y, and that all equals 0. Notationally, this seems much worse, but we're ultimately going to be doing the same thing that we did up here. And the idea is that by converting it into this kind of format, they are equivalent. Although I'd argue in this case, just doing the regular characteristic equation is easier. If you didn't get it, then that's something to look forward to in future math. Or not look forward to, depending on how you look at it. Alright, so let's go ahead and keep going then. So that is equivalent to if we pull out the s squareds, and we're gonna rewrite, how do we want to write something? We're gonna rewrite L of y over here as capital Y of s in the same way that L of f of t is capital F of s. Going off of that, we can then rewrite our equation as s squared minus s minus, what would that be, just 2? Yeah, the 2 from right there. 2 times capital Y of s. Okay, now I want to say minus this, what would that be? That would be, really I'd say plus 1 minus s times y naught. Yeah. Y naught minus y prime naught equals 0. Yeah, no worries. Like this is basically a proof one where it's proving that the general characteristic and the Laplace transformations are equivalent, usable to both solve an IVP. So it's kind of being intentionally messy, which is kind of annoying. Because then, yeah, if we rewrite it, we go ahead and get that. At this point, I'm just going to follow along with the proof so I can get this part done. Because this proof already is prepared. So let's see. We go ahead and rewrite it like that, and then we can factor down the bottom to get s minus 1 over s minus 2 times s plus 1. A similar state that we were at previously. And then we're going to go ahead and do partial fraction decomposition to get that y of s is equal to an a plus b over an s minus 2 plus b over s plus 1, which is partial fraction decomposition. Okay, that gets us that. God, some of these examples are devious. Plus 1 plus b times s minus 2. And now we have to say that we want a of s plus b of s to equal just 1s, which is from that singular s. And then the minus 1 is a minus 2b. Hey, 2b is negative 1. Alright, that gets us that a is equal to negative b by our first system, or by our first equation. And then we also get then that since a is equal to negative b, we get 3a equals negative 1. So a is equal to negative 1/3. Is that correct? That might not be correct. Did I do something wrong? I did do something wrong. Oh, because that's supposed to be a 1. Oops, that's why. A is equal to 1 minus b. So then, if we rewrite this part, we get a minus 2 times 1 minus... Oops, no. A is 1 minus b. Oh, so I have to rewrite a. Whoops. That was my problem. 1 minus b minus 2b is negative 1, which gives us that that's a minus 2, 3, we get b is equal to 2/3. Okay. Got it. So then, that implies that a is 1 minus 2/3, so a is just 1/3. So then, that gives us the equation y of s is equal to 1/3 over s minus 2 plus 2/3 over s plus 1. Write that a bit better, s plus 1. Then, using our Laplace transform that we know, or using our inverse Laplace, say that 1 over s minus a is equal to e to the negative, or to the at. We then get that y of s should be equal to, really, y of t. There we go. The inverse Laplace of y of s should equal the inverse Laplace. We bring out our constants. 1 over s minus 2 plus 2/3 Laplace, or inverse Laplace of 1 over s plus 1. I know you can't see all of that because it's covered. Oh yeah, because how am I doing it with my eyes closed? Oh, you know, it's yes, because the model is me. 100% has nothing to do with the angle that the camera I'm looking at. Has nothing to do with my phone being at one angle and my iPad being tilted at a different angle. No, it's all skill. It's all just really, really good skill. Now I'm gonna try and actually do math with my eyes closed. Let's see how this goes. So this would give us that y of t is equal to 1/3 e to the negative 2t plus 2/3 e to the t. Oh my god, I did that with my eyes closed, and it actually came out pretty well. Oh, I also did the wrong signs. That should be that. That's pretty cool. I did this. I wrote that equation out with my eyes closed. And if we notice, that is the same as this one. Hence, that's our proof that the Laplace transforms can solve IVPs. How that's easier, I don't know. Because that was one of the big selling points, is like the Laplace transform is supposed to be easier. For certain situations, of course. I think it's as you get more complex situations, if I remember correctly. Let me see if I can. Oh, that hurts my throat. Yawning and talking. Excuse me. Oh my god, sorry. Yeah, that's the best way to do it. Oh, here's my elementary Laplace transformation table. I was looking for that. If we want to look at just the generic explanation for what a Laplace transformation is, though, so if we have, that's a g, that is not what I meant to write. You know, a y squared plus b, or not squared, double derivative plus b single prime plus c of y is equal to f of t. Okay. Then we know that our Laplace transformation form is going to be in, I'm going to actually just start writing, excuse me, y of s is like that, s squared minus s y naught minus y prime naught plus b times s, and this will just be a regular y prime plus c, and this is just y of s, right? And that'll all equal f of s, capital F of s. And then, if we want to convert it into y of s, solving for y of s, we'll get that that is equal to as plus b y naught plus a y prime. So the nice thing about this setup is that if you have this exact formula kind of thing, and generally your initial conditions will have something be like y of 0 is equal to 0, y prime of 0 is equal to 1 sort of thing, you can just plug those in directly and it will save you a great deal of time, because those are easy ones. Like if I have y naught is equal to 0 as my initial condition, then I can just eliminate that whole term. Same goes for something like there. In fact, it's not crazy uncommon to have this entire first term, because this is just the first term of 2, this whole first term to get eliminated if you have the initial conditions of both y naught is equal to 0 and y prime of naught is equal to 0. So the chance of you even having that first term, not super high, because tons of IVPs rely on either the first situation or the second situation. And then if we can find a y of t to transform back, then we're good. How would I go about this solving a normal way? So in a normal differential, all right, so kind of like what we did up here, this is your like generic run through for a general characteristic equation, like general solution of one. This is what it would be. Oh god, my throat's already suffering because I'm like talking so much, because now I'm talking about math, so I'm talking much faster and I'm talking much more. I just drank so much water. Okay. So, if you were just solving this usual IVP, this is how you would go about it. The general way is to create a characteristic equation right here, solve for its roots, then you go ahead and plug it into a general equation. That'll look like that. Now, suppose you're given these initial conditions. Well, using those initial conditions, you plug in to your generic equation for t, and then solve for what C1 and C2 would be in relation to each other by a system of equations. And you do the same thing by taking the derivative of your generic equation and then plugging in your derivative initial condition. All right, so then you've got a definite answer for what C1 is, and you have a relation for what C2 is, so you can then say, oh, C1 is this, C2 is this. Then we go ahead and replace C1 and C2 to get our solution with definite constants for this IVP. Namely, what it's saying is, if I were to find the derivative and then the double derivative and have these initial conditions, it would this equation here would satisfy that. Draw a better circle. Oh, come on, I can do it. Yeah. Now, we have the option of doing that same thing as a Laplace transformation, where, let me see if I can bring a Laplace table on screen that cannot directly integrate. So that's where, honestly, we get a bit more complex. And I am a bit rusty on my Diffie Q, so. Because there's tons, yeah, there's a reason differential equations is its own set of courses. Is specifically because you have textbooks filled with different integration methods. Because of the terms never being with the correct derivative. Ooh, I see what you're saying. I think I see what you're saying. Because you also have stuff like step functions, and Laplace transforms can handle stuff like that, and step functions and piecewise functions and whatnot. Do we have a good example of that? Because, like, where's a good example? I know, like, I'm trying to think if you had an exact example, I would be able to. Let's see if I can find one line. I'm in high school and just a different, never thought of these are going to be this scary. They're actually not so bad. What they are is long. They seem intimidating and they seem scary, but in reality, it's just, like, you've seen derivatives. A lot of this is just algebra. Initial conditions aren't crazy. You see those in calc. The Laplace transformations have you just kind of reordering things. So, like, this chunk is the only chunk that's, like, definitely new. But even then, you generally have a table, so you don't have to compute the transformations yourself. And then from there, it's just more algebra. This partial fraction decomposition, that's an calculus 1 or 2 topic, depending on how your calculus chain works. Systems of, like, this is just a systems of that's just a systems of equations. We then equate it here, plug things back in, and then finally, this is the only thing that's like new to diffeq, is this Laplace transformation, where we take the inverse transformation and use its linearity here and here to then give us, boom, this equation, which is what we care about. And at the end of the day, we can just kind of plug things into our generic equation here, and then finally say, like, so this whole term is y of s, and y of s is just the Laplace transformation of y of t, so it's like we're just taking a function, doing a fancy transformation on it, and then that gives us y of s, so subsequently, if we can find y of s, then we can take the inverse Laplace to give us y of t. Looks scary. That's the thing about math, it's like lots of symbols, lots of words that kind of mean nothing. But as you do it more and more and more, then you see it definitely is not as bad as you might think. Is it fun? Well, that's for you to decide whether or not you enjoy it. Personally, I love it because it's like problem solving, and I love problem solving. Okay, we got this equation. All right, what is this example equation? Y prime plus 12y equals cosine of pi x over 12. I'm actually going to rewrite this as pi over 12 times x. We have an initial condition of y naught is 0. Which of the options are true? Oh. There exists a b for which the line intersects y in infinitely many points. Y is periodic. And, okay. So, if y is periodic, so this one we don't actually have to, I'm just thinking. Say y, or, yeah. Say that y is periodic. Or y of x is periodic. Then it has to be true that y equals b would intersect at infinitely many points. Now, it doesn't have to be true the other way, though. You could have, in theory, a function like Brownian motion. Brownian motion is something that no matter how much you zoom in, you can't actually take the derivative of. It's just like, it's actually what the stock market mimics. So it's not actually periodic, but this is still true. There is still a b where you can run through everything. As long as it stays within a certain range, which it does. Yeah, so it would be periodic because that's repeating, which means that if it's periodic, then the there has to exist a b, which that's true. In which case, it couldn't be increasing or decreasing because it's periodic. It's cyclic, it's repeating. It has periods by which it loops. So that one's more of just like a... This is differential equation stuff. So it really depends, because I know you were saying that your course is are a bit ahead of how like my courses were labeled. Like your Calc 2 is handling triple integrals and whatnot. That stuff, where I went to university, wasn't done till what we called Calc 3, but it could be like different terms and whatnot. Regardless, kind of brute force maybe, but I couldn't outright solve the differential equation. That stumped me. Let's see what we can do. Because my first thought, I think actually, yeah, Laplace transformation should be able to help here. We would get, so let's rewrite this. We get that S of y of s minus y not. Oh yeah, this should be doable. This should be doable. I'm pretty sure, at least. Is that plus? I just wrote the equation up here. Yes, plus 12. Whoa. Ah, thank you for the sub. I appreciate it, Radical Santa. Yeah, that should be 12y of big Y of s equals... Yeah, I can see why it would get tricky, because now you're getting this cosine of... How would you go about this? If I just treat x as t... Let me actually rewrite this, and then... Now let's take the... Oh, okay. Oh, yeah. I'm cooking. Now we take the Laplace transformation. A limit question for you? Yeah, sure. What do you got? I will get to it right after I finish this Diff EQ. Okay, yeah, so if we take the Laplace transformation... Yes, of course. You don't even have to sub. It's just throw it at me. Throw it at me. I'm more than happy to help. Okay. Oh, but IU. So if we go ahead and set it up just like we were doing the Laplace transformations, then we can actually take the transformation of that, which if I look at my Laplace table, which I have to find again because I should really just like have one stapled to my wall. Okay. Cosine of AT is going to give us s over s squared plus a squared. That's going to be s, of course, is greater than 0. Oh, this is weird, but not friendly looking, but yes. Okay. So what we do from here? We would go ahead and... Oh, this is going to be gross. This is going to be really gross because of that. That's the thing. So, by brute force, you did correctly answer it. And the main thing that you were supposed to see, IU, was that it was periodic. That was what you're trying to get out of it, which you could see from the cosine. That was important. I'm going to be honest. This is going to turn out messy, I'm pretty sure, because of that term I pointed out. But it is by no means impossible. Yeah. We would just have to set it up with... Yeah, what the heck, I'll go ahead and set it up. And what's my initial condition is that y naught is 0. Minus 0 plus 12, 12ys. So we just really get that ys... Yeah, just do this one step at a time. S minus y naught... Or, no, that actually we're just gonna get rid of entirely because we know that term goes to 0. Plus 12 is equal to s over s squared plus pi squared over 144. Y of s is equal to... Divide that, s over... Oh, God. That's disgusting. Okay, you know what? I'm gonna leave that to you to solve. Take it away. I'm gonna let you finish that one. It should just be a, it'll be gross. Oh, that should be a squared. But it'll just be a, partial fraction decomposition like we did previously. And then from there, you just have to do find the inverse Laplace transformations to get you the actual equation that you'll come out to. But yeah, like I said, it is doable with Laplace transformations. It should be, at least. Okay, now on to your Zide. Okay, so the limit of x goes to 1. We sum from k. Yeah, let me write this a bit cleaner. My handwriting is getting sloppy. So x goes to 1. The summation as k goes to 1 to probably infinity. Oh no! To 100x to the k. Oh. Oh, wait, no, wait. K to 100, is that what that's saying? And then... Oh, no, I see what you're saying. 100x to the k minus 100. Oh, x to the k is in the sum. Okay, oh, sorry. Is it just to infinity then? I'm so confused. The notation, some parentheses were mixed around. From k equals 1 to 100, okay. X to the k minus 100 all over x to the first. And that, you said, equals lambda. I want to draw a prettier lambda. Okay. Okay, is this correct? Oh, wait. Some x to the k minus 100 whole divide by x minus 1. Okay. All right, let's see what we're working with. And we want to find the summation. Okay. And we just want to find out what lambda is. Oh, the sum is only for... Oh, the whole sum is... Like... This is... What the heck is this problem? Yeah, it is. You have a geometric summation. If you're going towards infinity, this would be easier, but the fact that you're going towards 100 is gross. Like that? Okay. I'm gonna assume... Alright. I'm glad you're enjoying this, Edo, whatever. Okay, let's see. As x goes to 1 to the k, plug in that goes to 0. And this whole thing should equal lambda, okay. Let's see. Oh. Let me think. Because I want to just like... So like I said... Oops. That is going to go towards infinity, but the fact that x goes down to 1 means that, in theory, we're going to approach... That's how I'm thinking about it. We're going to approach 100. Minus 100 over 0, but obviously you can't have 0. So this is going to approach 0. Now, as something approaches 0, all right, actually leave that right there. So, like, say we have 0.00001, okay? So then you actually have 1.00000. So this is going to be slightly greater than 0. This, however, or let me change the colors on some of these. So that's going to be slightly greater than 0. This thing is going to cause our entire term to shoot up. No, so if you have 0 over 0 or infinity over infinity, then you have a problem. That's when you would use L'Hopital's rule. Yeah, exactly. So, yep, that's a good catch. That's a good point. So, excuse me. Let's go ahead and do that. Let's go ahead and, because it's just basically a polynomial, can we take some derivatives? because we're gonna get, if we take let's cap into the summation here. Okay, and then it should just be that, right? I'm not crazy. The 100, the minus 100 disappears. We just get 1 on the bottom equals lambda, and then we just have that summation, right? Oh yeah, for a geometric. The thing about that is that also goes to, well, no, a times 1 is, when in doubt, I have a big calculus textbook behind me that I can go grab. Let me throw in a cough trap real quick. This is fun. I'm liking this problem, it's weird. But my thought, Skylar White, my thought was Elopitels 4950. Okay. If this is for some sort of a exam, sorry, sum of digits of lambda is 10. Oh. Let's go ahead and look for anything in this book that might help us on series. Advanced sample question. You remove summation is a geometrical progression. Is calc too easy? Well, that depends. How how comfortable are you with the concepts? Because it does change person to person. I personally found that Calc 2 wasn't so bad because it was a continuation of Calc 1. At least where I took it. That can change from institution to institution, though. I'm curious, actually. Yeah, I'm... Hundred of x to the k minus 100, and then all that divided by oh. So I looked it up because I was curious. Are there any like strategies to give us in the right direction? And kinda cool. Yeah, you would end up with 0 over 0, which is a problem. So then it was what I had suggested earlier, which was take the L'Hopital's 1. Okay, is 1 to 100. Just 1. We would, of course, get rid of that 100. We have 1, which is kind of a moot point, so I'll just leave that there. Oh, now there's actually no problem if we plug in the limit. Of course. Because we've gotten rid of the divide by 0. So we just get k. So then just becomes the summation of k to 100. Interesting. So what did you say the book said the answer was? 50-50, yeah. Because, yeah, if you do that over that, and you just integrate it, you get 100 over 101, 2, and that just gives you 50 times, oops, 101, 50, 50. Yep. Yeah, when in doubt, L'Hopital's. Oh, sum of the digits, yeah, and that got to 10. That's a stupid question, the sum of the digits? I hate that. Yep. That was the first thing I got, was, I hadn't, the thing that stumped me was, I didn't just, like, integrate right after. Sorry, I didn't just, like, plug in the x minus 1. I was like, what do I do with that limit? Duh, I just plug in the limit. And then from there, yeah, I can just integrate. All right, glad that helped. Yeah, sure. That's what I'm here for. Oops. Ah. Hold on a minute. Sorry, my AirPlay thing is acting up. Okay, well, it's not showing up. Limit x to infinity of x plus 1 over x minus 1 to the power of x. Logs. Use logs, because you can do, oh, wait. Greatest in function, integer function, find x and x. Hold on, my AirPlay thing is acting up. Yeah. Please connect. Please connect. There we go. There we go. Sweet. All right, we're back. So before you even finish typing, yeah, the first thing I thought was L equals the limit. That's a, oops, that's a gross looking L. Equals the limit as x goes to infinity of x plus 1 over x minus 1 to the x. So my first thought immediately when I saw that, before you even wrote the rest, that looks so horrible. My handwriting's so bad. I also wrote out inf instead of writing the infinity symbol for some reason. It's not differential. No, yeah, if you got a question, shoot. I knew, but sorry, first I'm working through this one with Zaid real quick. So my first thought though is logs, because before anything, if the logs and the limits are in fact interchangeable, if I remember correctly. So my first thought would just be take the natural log of the limit as x goes to that of x plus 1 over x minus 1 to the x, and then we go ahead and change that to the limit as x goes to infinity of the natural log of x plus 1 over x minus 1 to the x, and then we can pull that x out in front. So then we would get that the limit as x goes to infinity x times the natural log of x plus 1 over x minus 1, and then because it's division, we can split it up even more. The limit as x goes to infinity of x times the natural log of x plus 1 minus the natural log of x minus 1. Yeah. Anyways, that's where my brain was going, Zaid. That's just like the first place I jumped to when I saw the x exponent. I don't. Let's see. Based off the what you said following, is that helpful? Find a fractional part in the greatest integer function. I'll come back to that though. Anyways, golden. Okay, let's see. So, yeah, I'm gonna head and draw a line right here. Okay. 89 factorial equals 10 to the... Is that 10 to the x times y? Or is that 10 to the x times y? Is the y in the exponent or not? That's important. Because that's what it looks like to me. Nothing quite as refreshing as flat sprite. How to get better at maths? Well, that depends on the maths you want to get better at. Ultimately, though, the trick is practice makes it perfect. It's the age-old adage, and it is true. However, based off the different things, there are different strategies to help you. There are, of course, shortcuts, but at the end of the day, it's understanding the theory behind the math is incredibly important. Like, For example, the hardest part of calculus is... and then times y. Okay. I'll mess with that, Golden. The height. So I guess first I would want to know, just for curiosity's sake, what is 89 factorial? It's going to be horrible. Find number of zeros in the factorial, that is the power of 10. Oh yeah, there you go. Look at that. Zaid coming in clutch. See, this is what I want. This is what I want. This is what I want. It makes me so happy to see mathematicians communicating and helping each other out. All I've ever wanted is a math community. All I've ever wanted is a math community. It makes me so happy. Everyone coming up with like different, because like I didn't know that theorem, so that's awesome. Legends theorem, I didn't know that. It makes me so happy. My first thought was just, I mean, if you just, however, yeah, if it's 19 zeros, then it's just 10 to the 19th, and then whatever exactly y would be. If y doesn't have to be an integer, then it's easier. Time to use that theorem. Legends theorem. Oh, Legendre theorem, French. I'm just sitting here and watching my chat. This makes me so happy. This makes me so happy. Just you guys. Oh my god, this is so sweet. This is so happy. Just see you guys conversing, sharing theorems. The variables. That's what you guys are, by the way. The chat name. You are the variables, and the variables are so adorable. I love this. I love this. Okay. So the thing I had about the limit question, this was my first thought to get started, was just immediately take things apart, and then from there, I appreciate it. I will go ahead and actually save this then. Let me write this down for myself, or I'll star it. All right, I bookmarked that page, so I will go ahead and post it in my Discord, probably later today then. I'll go ahead and mess around with it and see what I can find. But thanks for stopping by, Zaid. Oh wow, this stream's already been going on for an hour and a half. It's after doing a 2-hour Shin Megami Tensei stream. Ugh. Oh yeah, my Discord is available in the description of the stream, and in my stream channel description. It should be. If one doesn't work, try the other. I think they're the same. I know one of them wasn't working, but I think they should be working now. Oh, I didn't realize I switched songs. Or switched compilations. That reminds me, when is... Man, there was a new VTuber I just started watching. She's not new, but like I just discovered her. And she hasn't streamed since like Thursday, and I'm just like, stream! I want to watch you play more of Persona. Power Prime Factorial could have been used in that problem. Which one, Ayu? The one that Golden had? Oh, hold on. I actually need to write down... Find... I want to write this down. Find... And... This is fractional. And this is integer. Okay. Oh, this is a, sorry, greatest function. Okay. Bookmarked, and I will hop on that later. That one's complex. The problem? Well, think about the problem. I can see a better math, please. Ah! God, that was a great net crack. A wonderful feeling. Ooh. Let's see, where are we at for today? I'm like... I just went on a burst of math questions, so I'm like... Time to relax. Time for a nap. I actually haven't had lunch yet. I don't know what I want to make for lunch. Is it time to just shift this into just chatting? I feel like after an hour and a half, that's fair. Am I allowed to do that? It's my stream, I can do whatever I want. I'm gonna do that. Because I am somewhat drained. Chat, appear! There we go. Okay, that chat that it's showing up is way behind. It's tough, I joined it. Send it when you can. Bye. Nice to meet you as well, Zaid. It was a pleasure. Alright. What should I talk about? What should I do next? I need to charge a lot of stuff. I need to charge my iPad for work tomorrow. I need to charge... Well, no, my phone's actually been charging this whole time. You generally don't want to charge your phone for a long time, because it can wear down the battery life, although iPhones are pretty good about that. I get it tapering off the charge. But... They're good at tapering off the charge, but if I keep them plugged in for the entire stream, then inevitably the charge will degrade. And that's fine. Like, that's to be expected. I don't really mind. Phones are limited. They have a limited lifespan, as do all things. Entropy consumes us all. I wouldn't have ever every time, twice now I've done these like math live streams. I've done them before on Twitch, and then I shifted, but when I shifted over to YouTube, so I've done 2 of them. Some of my biggest my biggest live streams are playing Portal and then math, and that is not what I would ever expect. But to be fair, I guess. What did my foot just press? Okay, nothing. To be fair, there's like a million streamers, and then a good portion of those are VTubers who already do stuff like play games. And it's like, yeah, I do want to play games and stuff. Oh, you got an awesome question? Yeah, hit me with it. ABC triangle, okay. I'm currently playing with the Legos from the hand cam stream. This is some triangle. I'm very looking forward to it. I can't wait. Ooh. Okay, I'm gonna start writing this down now. Because now, you have my attention. How many degrees is A? Couldn't I just, I feel like I could relate things with, just using laws. Alright, so sine A is sine B plus sine of C over cosine B and that's all the info I'm given? My first thought is to algebra out some stuff using the law of cosines, perhaps? Yeah, my first thought is using law of cosines to try and mess with something there. That could be interesting. No, I don't think the law of cosines gets me anywhere. Oh yeah. Make sure to reload your stream every so often, because... I wouldn't say I'm considering it. I'm considering finishing just because, I am hungry, and I was going for a few hours before that. Would that be 90 degrees? How'd you do it? I'm curious. Yeah. How did you solve? Albeit, I would like to know. God, streaming takes more out of you than you realize. How do I don't know how people do it for like 12 hours straight. I think it's something you really have to build up to. As long as you're like willing to take breaks and stuff, I think that's probably important. Oh! Oh, is that a way to do it? Oh, that would be cool. It's like it was in high school entrance exam. By the factorization of sine and cosine into a product. Okay, yeah, that's cool. And then you're able to algebra run, then pi is able to speak. C to sub. Yeah. That's awesome. I gotta show that to some people then. I'm gonna save that one. I love that. What? Oh, a huge delay. Oh no. Well, since there is such a substantial delay, I believe it may be time to call it. And you won't even know I'm calling it until 5 minutes from now. But, regardless, as always, thank you so much for everybody who stopped by. Thank you so much for everybody who watched. Thank you so much for everybody who chatted. Everything to say, and I must say that it has been so wonderful and warmed my heart so much to see the variables all chatting together and solving math problems with each other, giving each other advice. People popping in to be like, how do I do this? How do I do this? How do I do this? I love it. So, as always, I have been Poisson Invariance, your mathematician and VTuber, and I will see you next time. So, bye-bye!